So welcome back to our channel, that is AI Next Generation. In this particular video, we will just implement one of the famous data set, that is brain tumor. Okay, so with the brain tumor data set, you will have the images. On the basis of that particular images, you will able to classify, you will build the model. You will have, that particular model will able to classify whether the person has a brain tumor or not. Okay, so brain tumor, I think you know very well, whenever extra cell that is developed inside our brain, that also cause the cancer early stage. We have to just so that doctor, they are just seeing from that part, they are just seeing and visualizing from that particular images, that is MRI, they are just doing of the brain, and from that they are able to detect whether the person is suffering from they have the brain tumor or not. Okay, so similar here, we have all the images. Okay, images of the brain tumor. One folder will consist of all the images that the person having the brain tumor, and the other person having all the images the person does not having the brain tumor. So you want these particular images to fit to that particular model, so that model will able to recognize this one, and it will, whenever the model will train, then it will really works on real world data set. Like you can just feed directly any images, so that particular model will able to predict that one. Okay, so this is the main problem we are just doing today. So first of all, in this particular data set, I will just give you the link in the description of this video, so from directly you can just download the images of this particular data set. Okay, so yeah, so first of all, what we can just do, this even brain tumor detection. Okay, is tumor. Okay, so here, so what we will just implement brain tumor detection with the CNN model. Okay, we will use PyTorch as a deep learning library, and we will use CN, convolution neural network. Okay, so we will build from the scratch of the CNL, like all the layers. We will not use any pre-trained model in this particular video. Okay, so let's get started. So first of all, what we will import some libraries we are going to use. Okay, so what we will see, we can just use import numpy, that is as np, all the numerical operation you can just do with the numpy. Import pandas as pt, loading the data frame or manipulating the data frame. And also we will use import matplotlib. Okay, pyplot as plt to visualize the data set. Then also we will import the operating system OS. Okay, this is the operating system we have to perform. Okay, then after what we will just import, now we will import the torch library. Okay, all that torch library, like what we want to do. First of all, we will import torch, basic torch. Okay, so you are just importing the torch. Then after you will import torch dot nn as nn. This is here you will find all the neural network from class and everything you will find here. Here this particular library. Okay, so the next we will use import torch dot nn dot functional as f. Okay, so here you will get some ReLU activation function, all the different kind of activation function you can just get from this functional. Okay, then after that we will also import dataset. Okay, from torch dot utils dot data import dataset. Okay, so here we will import, this is basically whenever we will build our custom dataset. Okay, so this particular we will inherit this dataset from that particular what we are just building custom dataset. Okay, so at the time we will talk more depth about this particular dataset. Okay, and also what we will just import, we will also import, we can also import shuffle. You can just import from sklearn, from sklearn dot utils import shuffle. Okay, and also one more library you are going to use this, that is pil. Okay, from pil import image. Okay, It is basically image data set. Okay, so everything, all the image you want to read different type of images, whether it is a JPG format or PNG format, and how you can just convert with the help of PIL library. You can just do this stuff. Okay, so I think we have imported some basic library. All these library we are going to use in this particular video. So if we will want to use any extra library, we can just import afterwards. So we will see. Okay, just run this one. This already has been run. Then after the next step, we will see whether the particular whatever you are just using laptop or desktop, whether the particular they are supporting GPU or not. Okay, if that they are just supporting GPU, you are just moving all the particular array to a tensor, like all you are just moving to all the tensor to it GPU format. Okay, so either can be a CPU, either can it be GPU. Okay, so for checking that, just write import torch dot CUDA dot is available. Okay, this is how, if that particular system, if this particular CUDA is available. Okay, so you are just moving this device equal to torch dot device. This is how we are just doing in this particular PyTorch. Okay, so and else if it is not there, then change to device equal to torch dot device CPU. Okay, I think you don't have any doubt, just run this one. Okay, so these two things we already done. Now the next thing, this is the most important, what we are going to use, that is basically what you will use, that is a custom data generator. Okay, I will just mention here custom data generator. Okay, so what does it mean? Okay, so it basically says that what here you will do, you will make a class. Okay, that class will inherit the all the properties from this particular parent class, and the parent class will be basically data set what you have just imported here. Okay, this is particular an abstract class. Okay, so abstract class basically means what the method, all the method what they have just defined inside that particular class, you have to define there also. Okay, and if you want to read more about the abstract class, I will also make one video related to the oops. Okay, so here just in the abstract class basically means whenever you are just inheriting, whenever you are just inheriting all the properties from the abstract class, whatever the method they have just defined, the abstract method you have to implement in this particular child class, or child class what you will define now. Okay, so parent class will be your data set, that a data set that will be a basically you can just say that is a abstract class. Okay, how we can just define, I will show you first. Brain MRI data set. Okay, you can just do this one and just pass data set. Okay, now what you are just doing, you are just inheriting all these property. This is the child class, brain MRI data set is a child class, and this data set is a parent class. So this parent class is a consist of a abstract method. So if any particular class contain the abstract method, they automatic become a abstract class. Okay, so all the method what you have to what there it is defined, you have to define in this particular this class, and you have to implement that particular method, and with that what functionality they have used in the data set, they will be hidden, okay, from us. Okay, so this is some logic of the abstract class. Okay, and also I think you have to import one more library, that is a glob. Okay, so glob is basically, it works like a iterable. Okay, from glob import glob. What does it mean? So it's basically says that when it basically says that if you're suppose if any folder, in one folder you have all the JPG image. Okay, so you want to extract all the JPG image, then you can just use with the help of globe. In that one folder you have also JPG image or PNG image. Okay, different type of format of the images. What you can do, you want only all JPG image, you don't want any other PNG image. Okay, you can just use this help of globe. Okay, it's like it recursive, it iterate through. Okay, so we will just look this thing whenever we are just building this particular method. Okay, sorry, this particular class. So first of all, what you are just defining, you have to define the constructor, and here what you will pass, self comma, first of all, data directory. Okay, so data directory, we will just data directory basically means the path of this particular data set. Okay, and then after that, we want to resave. Yeah, we want to resave, just write true. Okay, and then after that, height you have to mention. Height, we will pass by default, we want height as 128 and width also as a 128. Okay, and then after that, what you will just write, that's it, I think. Even you can just go for the auto encoder. So if you want auto encoder, you can just implement auto encoder. If you don't want, then that's no problem. Okay, okay, so this was I think we can just go for the also auto encoder. We will see both CNN and auto encoder to implement this brain tumor detection. Okay, so what you one more parameter you will pass, that is the auto encoder. Encoder, and just write equal to false. Okay, if you don't know about the autoencoder, so autoencoder is basically what you want to do, you want to reconstruct what image you have passed. Okay, means input image what you are just passing, suppose you are just passing image of a cat, in the output also you will get the same image of the cat. So first what you are just doing, first you are just reducing all the features, you are just extracting the most important feature from that particular image, and then after again you are just reconstructing that particular image. Okay, so this how we will also look about the encoder and decoder. That is the concept of the auto encoder. Okay, so yeah, then first of all what you will write, just write self dot data directory directory equal to data self sorry data dir what we have just defined there. And the second thing what we can just keep the space, it will, yeah. And then after self dot number of class. Okay, even we will just define the number of class, and how you will just define the number of class, that you will not take input from whenever you will make an object of that. So you don't want to take number of class input from by the user by different object. Okay, just write number of class, basically you with the help of globe you will able to find. Okay, so globe what it will do, it will do that data dir. Okay, so you are just selecting from data dir, and then after plus, and then after you are just giving whether it, I think no and yes, there is only binary class, that's what you have. Okay, so this is the all the no. Okay, this is what you are just constructing, this one I don't think so you will have any doubt. Okay, and again self dot yes class. Okay, okay, so here also just write globe dot sorry globe data, and just in place of no just write yes. Okay, so you have only two class in this particular data set, either yes or no. Yes means you have the brain tumor, and no means you don't have any brain tumor. Okay, that's what you are doing now. So this how you are, you will this, and what I'm just writing this one again I will show you in the data. Okay, how you have to write this one. Okay, the star means you are just selecting all of the no, and yes means all of the yes. Okay, this is the data set. I will just give you the link of this, I will just give you the link of this data set, from there you can just directly download. Okay, this is what I was speaking. Okay, this is yes and no and what is contains. And the third thing is what you have to do, you already, then after that you will say self dot height, already you have defined there, height equal to height, and then after self dot width equal to width. Okay, then after that self dot reshape, and then after self dot auto encoder. Okay, equal to auto okay. So what you have defined everything, that what you have just defined everything. Now what you have to do, now you have to give the labels. Okay, labels, you will make a one particular list that contains all the labels. Okay, all the labels of a no class, and one list all the labels of the yes class. Means you want to separate these two data set. That is, you want to keep all the non-tumor, that particular image which that does not represent the tumor, then you want to store in the one list, that will be labeled as no. And if that particular image has the brain tumor, then you want to store in the list that you can just with the help of no and yes class. Okay, we will see this one, don't worry. So what we are just writing labels, and you just write the for I in range. You want to give the length of all the self dot yes. Okay, even this one first we will create for the no self dot no class. Okay, so what does it mean? All this in all, it will be just what it will do, it will iterate through all this directory, first of all no, and it will collect all the no images that does not contain a brain tumor. Okay, this is how it will go. Then after that, what you can just do, this labels belongs to all the no class, and then whatever we can just do, then after that you have to select all the yes class, all the no class you already have selected, and then after that you will select for the all the yes class. Okay, then how you will just select for that, just write the labels and for that also. But here what we have to return, okay, so you have to return whether all these particular that class, okay, all these particular class, if sorry for that, all these particular class which represent this particular for loop represent all the that particular image does not have the brain tumor. Okay, that does not represent the brain tumor, you are representing that thing with but zero. Sorry for that, it was some Wi-Fi issue, that's why I was just my mind was not there. Okay, and then after that for the years, where in that particular labels, if the image contains the brain tumor, then you will represent that thing into one. Okay, you can't directly pass no and yes, that is the string format, you have to pass in the integer format to that particular model. Okay, then what you will just write here, labels again, you can just go, you want to give everything iterate and iterate, then how you will just write here, just write for I in range, just write, you will write the same thing, but in place of no, now you are doing for the yes. Okay, length of self dot yes underscore class. Okay, is how you will read, and it will return whether if that particular image contains the all the images with the yes tumor. Okay, you will represent as one. Okay, so one represent for the tumor, have you have having tumor, and zero represent you don't have any having tumor. Okay, so I think you have clear with this, you don't have any doubt about the labels. Okay, so you are just merging both 0 and 1, that's why you have done plus or equal to. Okay, equal to that particular labels. Okay, then after that what we have to do, then after you have to do image links. Okay, so image links, again I will explain you what does it means. Okay, so it basically means all this particular self dot, you are just extracting all the images links of this particular, like you are just extracting the directory of the yes and whole directory of the no for every images. Okay, because every images will have different number, like y1.jpg, y10.jpg. Okay, y100, 102, this all the you are just extracting. So for this particular path will be the different. Okay, for this will be path will be different. Okay, that's what you want to do. Okay, so you are just adding this both. So how you will just add, self dot no underscore class, and here what you are just doing, okay, self dot plus no underscore class, and then after what you will just write self dot yes underscore class. Okay, so I don't think so you have any doubt in this also. So now we will move to the next. Our next will be basically, yeah, so based our next, what we already have extract the images links. Now we will move to the data frame. We will just create one data frame that will contain the image links and that particular labels. Okay, so again we will see this one, just create a one data frame, self dot data frame. Okay, you will write pd, I think you know how to create a data frame. Okay, what you will just write here, you will just write here, you will just the first column you will represent for the image A. Okay, you have to write in the string. This is the first column you are just creating, and you are passing all the links of that particular or the directory of every images. Okay, that what you have stored in the images links. Okay, just write image link, that's no problem. Okay. And then after that you have you one more columns you will take, you will create, that will represent for this particular labels. Okay, you just write labels, and just this is the key, and this all the value contains labels. Okay, that's what I am expecting, because labels, in this particular labels, you will have, you are just combining 0 and 1. That's what you have done, because a list, you are adding list plus list, that's what you are doing. Okay, so in the labels you will, all these particular image with yes represent as 1 and no represent as 0, and image link means you are just extracting all the image directory. Okay, then after you are just creating the data frame. So I don't think so you have doubt till now. Then after you will also go for the shuffle, self dot shuffle. Also you can use the reset index. Okay, so that it does not, every index will be in the arranging or ascending order. Okay, you can just say, or it should be not be mix up, you can just say. Okay, so you just write self dot data frame, and then after what you to reset index, just write reset index. Okay, and here you just plus in place, because you are not storing in any variable, just write in place equal to true, and also one more parameter, drop equal to true. Okay, so I don't think so you will have any dot, you are just resetting the index. And this was this over for the data frame. Now the next step, we will move to the particular creating the method. Okay, we till now what we have done, we have just in all these variable what we want. Okay, we want to in this particular class we have just done. Then after you will create one method. Okay, that method already have been that is the data set, that is the abstract class. Okay, so you will have the abstract method, there is a abstract method that is of the length. Okay, length that define the total number of data in your data set. Okay, total number of images in the data set. Okay, so for that what you will just write, I think it's really easy. Okay, so what you have to write here, just return and just write length, that's it. Length of self dot no class plus length of self dot es class. Okay, so I don't think so you will have doubt in this also. So this particular will return the length of all the images in this data set. Okay, then after also you will have one method, that is also an abstract method, that is a get item. From here you will get the features, the image and that particular labels. Okay, just write def. Okay, so pre-processing step is a really you can just say it is tough one as compared to the writing a model or writing a training methods. Okay, and even it is much different from the TensorFlow. Okay, in TensorFlow you are just writing image data generator, but here in the PyTorch it is a different case. Okay, you have get item. Okay, okay. See then after here you will pass IDX represent for every particular index. Okay, so what you will just write here, now it's really important thing for because you will pass one by one image and you will give the labels, you will extract the image, you will give the label of that. Okay, then how you will just write, you will just first create a list of all the images. Then here you will write self dot data frame, you already have created this one. Then here what you will pass, I want from image column, because here in that particular you have just created a data frame or pandas data frame that consists of the image columns and labels column. Okay, so what you will just write here, just write image column that represent all the images, and then in from that particular you want to extract the idf that is represent one by one it will go. Okay, because you are just creating a method. Okay, this method get item, for the first image it will go to that particular image and that extract the index, means index particular, if we'll go for the 0, this particular if it is index is 0, then particular one first row image will be extract, then after index is 1, second row image will extract. This how, this is the only the you are doing indexing. Okay, So I think it's over. Then similar what you can just do, label also, label list. You are just creating the image list, because you one list will contain all the images, and another list you will create all the labels of that particular images. Okay, because image list will be your features and label list will be your target in this particular model. Okay, so what here you will write the same thing. Okay, self dot data frame, and here you will just write the same as it is. You want labels column. Okay, from this labels column you will write itx. Okay, so I don't think so you have any doubt in this. And then after you have extract the images list and that particular label list. Okay, now the third thing you will just use, you can just create also, if there is if may error it will come, then you have to just skip if this particular type of this image list is a string. Okay, because image list is a string, what you are just writing string, then what it will goes, it will say you can just store that particular in a list. Okay, like image list equal to, just create a list, you'll just write inside the list image list. Okay, then after that also what you will write, if they and also you will just create in one particular instance. Okay, what does instance, it will label that all particular labels what you're just doing, you want to change that particular in the integer format, what you want to do. Okay, just write if this particular no, is in. Okay, so what you just write a label of this particular list. Okay, and list, and then after that what you will just, from that you want only the values. Okay, values will only the you don't want the list, you want the values inside that particular list. Okay, that what you are just doing. Then after that what you want to convert, even you can just convert into np dot init 64-bit what you want. Okay, that's it. So in this particular you will select for all these particular instance. Now here what you will just write here, label list equal to label list dot values. Okay, that's it. So this I don't think so you have any doubt. So only you are just writing the condition. Okay, if this particular condition, if the type of image list is a string, you are just creating in the a list. And if this, if it is not an instance, like if it not any floating or any other value, you are just changing into integer, the data type, and you want that from all the list, you want only the values of that. Okay, so you have done this one, and then after that what, now you will convert the images to a array. Okay, or tensor, what you can just say. Okay, so how you will do this one, I know this is really this pre-processing task is really tough, but hope so you have to do this way. Okay, so what, first of all what you will just create an empty array. Okay, so empty array you will just create image, the empty array image array, you can just write here, just create an empty array. So then after what you will just iterate through all the images from image in image list. Okay, image list contains all the images, so that you can just read this particular image, and you can directly convert that image to a pixel or array. Okay, because you can't directly fit image to a model, because computer they don't understand what is image, they understand only the pixel. Okay, so that's why you're just converting into array. So it array is basically the array number. Okay, so image is equal to image already I have just shown you, pil library, from there you're just opening this particular image from this image. Okay, okay, so what you have just doing here, and then after that, so this how you are just opening this image, and you are just converting this particular image to L. Okay, sorry for that. Okay, so then after that you will write one more condition here. So one more condition will be there, like if that particular, if self is not resave, if you want to resave. Okay, because already additional information I have just passed, you have resave equal to true, means every image you should keep in the same dimension, because whenever you will fill that particular image to a model, so it should not give an error. Okay, so you are just making every image as the same dimension of height and width. Okay, so what you are just doing here, you are just if that particular self dot, if it is a receipt is true, then what you will write, image equal to image. Here you are just converting into array, means you are just opening this particular image. Okay, now you are just reshaping that particular image. Here what you will write, image dot resize, that's it. And here you will write self dot resize. Here the self dot resize, here self dot height, it will just store. And then after self dot, okay, so here you are just resizing this particular every images. Then after what you will just write here, array, you will just create an array. So that you want to convert that way, np dot as array type, that's it what you are doing. And here what you will just write here, images, you are just converting images to an array. Okay, so I don't think so, I have done some mistake. I think a as a double r-a-y. Okay, so I don't think so you have any doubt here also. Then after, if you have any auto encoder, if you want to use auto encoder, okay, so that I think you can just skip for now the auto encoder part. Yeah, auto encoder part we can just skip for now. Okay, whenever we will train this model. Okay, so even in the next video I can just go for the auto encoder, don't worry about that. But the main task here to implement us how we are just training our model, okay, using CNN. Okay, so we hope so we have done till now this. Okay, so now again what you want to do here, you want to return a particular, but you everything that is in the numpy array, but you have to convert this thing into a tensor. What you have to convert this all this thing into a tensor. Then how you will just convert this thing, so you can just use, I think you can just return in place of return only you will write everything. I think don't worry about that. Okay, so yeah, just wait 1 second, I have to just look out. We already created the image array. Then after that, yeah, it's really work fine. Yeah, it's really work fine. Yeah, it's so fine. Okay, so okay, yeah. So I don't think so you have any doubt in this. Now move to the next part, that you have to just append in this image array what you have just created. You have to append all this array, okay, what you have just read here. Okay, this particular array you have to append there. So for that what you will just write, you will write you have to just, I think you can just use autoencoder, because whenever you are using autoencoder, whenever we will train this particular model, because autoencoder is really easy, you don't have to do, because it is reconstructing, then after because it is reconstructing what you have given the input to that particular model, okay, that same image. So even you can just go for the autoencoder also, but for now I think, yeah, let's see if if it is work fine, then we can just skip that part. Okay, for now just add this particular from a image array dot append array. Okay, leave it for now. That what you want to return this thing, that is really what we want to return from this particular for loop. Okay, so you want to return, okay, you want to return a list that contains, you have to convert this particular toss to a you have to convert numpy to a toss tensor. Okay, so what how you convert, just write tensor. Okay, then after you have to just pass the image array, that what have we have append there. And then after you have to write device. Okay, device we already know that device equal to, just write device, means whether the it is will be, it will have the particular, what we can just say, if we have the if we have our system or our if whether it our laptop or our desktop, whether it has CPU or not. Okay, what you are doing, if that particular system, if your system is having the GPU, then it will convert into a GPU array, that particular tensor will convert into GPU. Okay, that what you are just doing here, again you have to convert the labels also to a tensor. Okay, then after that what you will just write here, label. Then after label list, I think we have just written, and that you just convert that, you already converted that one. Again you have to write device equal to device. Okay, yeah, so we have done many things. Again you can just create one more method. Okay, that is the representation of that particular, yeah. Okay, you just write self, that's it, and just return this data frame. Okay, return string of all this particular self dot data frame. Okay, we want only the first 5 row. Even you can just write 10. Okay, that's it. Okay, just run this one, hope so if it will run. Why it is giving the error? So position argument followed by keyword argument. So what I have done mistake, torch tensor we have just imported image array, then after device go device torch.tensor, then after label, yeah, torch.tensor go to label. Okay, so we can just look through what we have done the mistake. Autoencoder we have pass, width we have pass, height we have pass, and reshape also we have pass, data directory also we have pass, and self we have pass. Okay, what's the mistake? We can just look out. Even for the autoencoder we have not mentioned anything, but you can just say okay, no problem. Let's see what's the error it is. Self dot reshape. We are just returning this particular, we are just adding this from every array, then after you are just representing in line particular 48 torch. In this line only it is showing me error, so it's what torch dot tensor image array. Oh, okay, that's, sorry for that, it's mistake of bracket. Okay, wow, device equal to device. What the mistake in this? I think we can just pass device also, because we have not mentioned the device. That can be device, because we have not mentioned anywhere device, what type of device we are going to use here. Okay, so for that what you can just do, you can just create a data frame you already created. Okay, so you can just do one thing, torch the tensor. From there you have to write everything. Device, I think there is some bracket problem, I think, because okay, I got it now. Okay, so you have to write in the one torch.tensor, you want to convert that particular array to a tensor. Okay, that numpy array to a tensor, and that particular device to a torch GPU or CPU. Okay, similar you are doing for the labels. Okay, that what you are doing. Okay, so that was the mistake. Okay, so now it's run. Okay, so we have done the everything that's related to the custom data generator. Okay, so then after that what we will just load this data, then we will see data set. Then after that just write brain data, and here what we have to pass, first of all you have to pass the directory. I can pass from my drive, just copy this path. Oh, this copy path, and then after that just paste, and then after that just run this one. Okay, because I think everything is by default value. Okay, only you have only the self directory, and rest they are a default value. You can just change, or you can't change. Okay, by default it will be what you have just created in this first particular class or init method what you have just given. Okay, so just run this one, it is running. Then after that from data set, okay, even you can just print this data set, so you can just see this one how you will just write. So print data set will just print you the represent what you're just writing the data set. Okay, this top 10 it is has been labeled because the first 10 already is 0 0 0 up to what, and then after that particular, even you can just pass the length. Let's see if it is working or not. Yeah, okay, leave it for now. So what we have done, I think it's clear to you. Okay, so because we have just represent this particular method, so that's why whenever you are just printing this one, whenever you want to printing this data set, so this particular method is invoked. Okay, so yeah, hope so we have done I think many things now. Then we can move to the particular next thing, and next thing is that model building, and it is really important. Okay, so model building is also a crucial step. So in that, what you can just write here. Okay, so now we will build our custom CNN model. Okay, so what you just write, you will just write a class. Okay, so class, from the class you are creating brain tumor model. Okay, and you are just inheriting from nn dot module. So again, nn module is your parent class, and this is your child class. What you're just writing, because this particular parent class, all the function already have been implemented by the PyTorch. Okay, so you don't have to write again and again. You then after that just create a constructor in it. Then after just write self. So we will just use the super to initialize the parent init method. Okay, parent class constructor, so that you don't have to write again self dot everything what you are just writing there for the convolution layer or layer everything. Okay, so I don't think so you will have doubt till now. Then after that you will create a convolution layer. Okay, self dot convolution, the first you can just keep in the nn dot sequential. What you can just do, so you can just write this thing. Inside that you can just pass parameter, that is nn dot convolution 2D. Okay, you can just do this one. Okay, we can just see. Okay, so nn dot convolution 2D means you are just creating a convolution layer. Okay, so this particular layer will, the first parameter you have to pass the number of input channel. Okay, so we are just we are just converting every channel to a particular black and white or grayscale. Okay, so that particular will have only one channel. Okay, then after that the second parameter you have to pass, that is our output channel, and then output channel is basically the how many number of filter you want. Here I am just mentioning 256 total number of filter I want. And the third parameter you can just pass kernel size. Okay, so kernel size basically is every filter what dimension you can just pass. So I want only 3 cross 3 for total 256 kernel. You have total 256 filter, and each filter has a dimension of 3 cross 3. Okay, what you are just writing here. Then after that what you will write here, nn dot max pooling, max pool. Okay, so here you will just write max pool 2D. Okay, not 2D, not 3D. Okay, and here you will just write I want only the what size you want to pass, only the kernel. You can just pass 2 cross 2 comma 2. Then after that again just create one more convolution layer, conv, just you can just write here, and here you will pass the what output will be there, then it will be input for this. Okay, 256 comma total number of filter, how many filter you want to pass. Okay, this time we are passing 32, and that kernel size of that. Okay, so you are just passing every filter size will have 2 cross 2. Okay, so this because we are just downsampling now, that's that we are just using in, we can use also max pooling, no need to use from after this. Okay, so this is how the first convolution layer we have just created, that consists of the nl dot convolution layer you are just using. Then after you are doing the max pooling, then after again you are just creating in one more convolution layer that acts downsampling, because at that case you are using kernel size as true. and that every filter total you are just passing 32 filter, and that each filter has the size of 2 cross 2. Okay, then after that you will just create a fully connected layer. Okay, so self first fully connected layer you are just creating self dot linear equal to, then after that what you will just write ln dot linear. Okay, here you will pass the number of parameter. Okay, so you can just even create, I will just write the shortcut how you can just write any. This is the basic formula, n minus f plus 2p by s plus 1. Okay, this is the basic formula from where after every convolution operation what will be the output of dimension of that particular image. Okay, so during the first it is a dimension is 128 cross 128 we already have seen this one. Okay, so and represent the number of dimension, this means particular width and height dimension. So you have to just pass during the first conversion operation 128 minus filter the size. Okay, so filter size is 23. Okay, so during the first operation what it will pass here, you can just do, so this is only making because, so whenever you are just fitting that here the input layer what will be there, a number of neurons in this particular, if whenever you are just creating ANN, that ANN will be hidden, acts a hidden layer inside the convolution layer. Okay, so here you are just extracting the most important feature, you are using the filter different, then after you will fit that particular most important feature to that particular in a fully connected layer. Okay, so what for that what will be the input, that depend upon the number of pixel you have. Okay, after extracting this one, so you can just to use this formula. Okay, so and basically 128 minus, and filter size is 3 plus padding you don't have, instead by default is 1, and even you can just plus 1 you can just do. Okay, so what is the output, so minus 2 you have 126 will be the output, 126 cross 126 into number of channel will be 256, this will be your output after performing this convolution layer. Okay, so by using this formula, then after that what you are just doing, you are doing the max pooling of the 2 cross 2. Okay, so it will what, it will just use the most important feature among the, by using 2 cross 2 of that particular dimension of the max pooling, it will just iterate through all this pixel, and from that particular pixel it will accept the most important feature. Okay, so you have 2 cross 2 means you can just divide this number of dimension 126 divided by 2, but max pooling does not reduce the dimension of the channel. Okay, it will reduce dimension of the image only. Okay, so what you have to write here, so whenever you are just dividing 63 cross 63, this will be the dimension of this particle, this will be the perform after performing the second convolution layer. So I don't think so you have doubt till now. Okay, you don't have doubt till now. So then after that what you will just write here, so after again you are just performing the same thing, then here what you will just write here, 63 minus you have kernel size as 2 plus padding you don't have. Okay, so padding you already means by default it is 0. Okay, and stride is by default it is 1, so in place of padding what you are writing 0, 2 multiply 0 equals 0, and by stride 1 equal to 1. Okay, plus 1 what you will just write here. Okay, so what will be the output, it will give you output 62. Okay, so the final dimension of image will be 62 cross 62 cross 32. Okay, this will be your output. Okay, now this will be the output, now you will fit this particular to a convolution layer. Okay, what you will do right here. Okay, so let's see after that what we can just do. So first of all you can just pass 62, and then after that I want from the total, and then after the hidden layer size you are passing 128. Okay, so similar also you can just build second linear layer. Okay, so you can just copy this one, you don't have to write again and again, just write control V, control V. Okay, we will create, I think we will create the three convolution layer, the one will be the means three convolution layer means we will create three fully connected layer, one fully connected layer, inside that you will have total number of three hidden layer. Okay, so you will just write here 2, here you will write 3. First you will pass 62 comma 28, then after that for the second will be 128, then for this 128 will be the input, and what will be the output, 64 will be the output. So I don't think so you have doubt till now here. And then after that what you can just do, this will be the output, Okay, so this is, then after that what you will use 128, because after that you can just flatten this image. Okay, so then how you will just flatten this image, then you can just do this one, no, self dot flat, you can just create in one that and then from nn dot flatten, it is just directly convert all the two, because here you are just you don't, you whenever you are just feeding any neurons to a ANN network, artificial neural network, in that what you have to convert everything, you have to do to flatten, because you can't directly feed two dimension matrix to a particular AN, because in the input layer you will have all the neurons in the one, that is in the 1D format, so that you have to convert 2D to 1D, you can just convert with the help of flatten. Okay, so it will just convert, and then after that what you will just write here, so after that you will just write total number of, you can just multiply this thing, so this will be the input for this particular final layer. Okay, so what you will just write it, I think after multiplication you will get 2 1 2 6 9 7 6. Okay, and what will be the, and here after that you will pass, you have only the two, you will keep the in output neurons, how many neurons you want to keep in the output layer, only two, because you have only true and no. Okay, means you have yes or no, means if the person, if that particular image has a brain tumor, then that represent by the 1, and if it is does not have a brain tumor, then represent as a 0, means you have in output layer you have only two neurons, that's what you are just passing. Okay, so I don't think so you have any doubt in this. Okay, so yeah, now move to the next what we have to convert, sorry for that. After that we will create one more method that represent forward. Okay, forward method. So forward method will what, it will just constant self comma x. Okay, you can just directly pass. Okay, so first what you will just write here, self dot convolution, you will just pass from the self dot convolution layer the first convolution what you have just built, and you will pass the images. Okay, then after that it will perform the all the operation, then after what you will just write here, then after top of that you will just write ReLU activation function. Okay, because that particular neuron you want to deactivate, that does not contain any information, that negative you want to just deactivate. ReLU or indirectly is formula is from 0 to particular x. Okay, positive whatever you want, and then after that what you are just passing this, similar you have to pass again for the fully connected layer. Okay, that is and what you just passing here, for the linear one you will pass here x, and then after from top of that what you will just apply ReLU activation function. Okay, same as it is, I don't think so you will have any doubt in this. And then after that you can just create a self dot linear 2. Okay, linear 2 I think you have defined, and then after just write x, then after just you want to create this thing, you want to convert all this 2D image or 3D image into a 1D, because if flatten means everything it will convert into one dimension, like it will just convert into like this. Okay, so you can just directly feed this particular to a neuron input layer or hidden layer or any near layers. Okay, so what you will just write, self dot flat, already we have just created here, you can just see, and just pass x. Okay, then after this will be the final layer. Okay, self dot linear 3, then after you're just passing x. Okay, and then after you will just return x, this will be your output that is predicted by your model. Okay, return x. So what does it mean, that whenever you are just creating the forward method, so whenever you will use the loss as a categorical cross entropy, so by default soft mesh activation function is come hand with that particular categorical cross entropy. That's why you are just not writing one more activation function, that is a soft mesh activation function. Okay, that particular all the whatever you have in this particular output, it will just convert into probability, and which has highest probability, that is your output. That's what you will do. Okay, wow, it is saying it is not defined because you have not given the comma. Okay, just run. So even you have not given the comma for the, even after the max pooling also we have to do this one. Just run. Okay, so you have just created the custom CNN model for this particular brain tumor. Okay, then after that what you will just do, you will create the object of this particular model. Okay, how you will just create the object. Just write model equal to brain, am I right, model. Okay, just say you. Then after that, what you will just move model to device. What you will do, because if your system consists of the GPU, then you want to move everything to GPU. Okay, device, I don't think so you have a doubt. So you have done this one, you have make the model, so you have done the data set also, the two big things you already have done. Then after that you have to create a, now you will just train this particular model. You have everything. Now you will just write the training. For training model, what you have to know what you will have the loss function. You have to first say that which particular loss function you want to use and which particular optimizer you want to use. Okay, so loss function you will just write here, loss function you want from NN, you want cross entropy loss. Okay, so what cross entropy loss means whenever you will compare with the actual and what the prediction by the model. Okay, so whenever you will use the categorical cross entropy, this cross entropy, so first of all it will use software activation function. Okay, then after that it will just say whether your particular what is the error in this. Okay, so yeah, so then after that you also have to write optimizer. Okay, which optimizer you want to use. Okay, so optimizer basically means whenever during the back propagation gradient descent will work. So which particular optimizer you will use to change the weight of that particular model. Okay, so you can just create that thing also. Okay, one second, I'm just charging my MacBook, connecting my charger. Sorry for that. Okay, so then after that what we'll just write optim dot Adam optimizer we are going to use here. It takes two parameter, one takes model parameter. Okay, this is the model parameter what we are just passing. Okay, okay, so initially it will just initialize with the random weights. Okay, that's it. So and this how, and then after you are just running. Optim is not defined, why? I already have imported now optim. Oh, okay, I have not imported this one. So what you just write, import, you can just write here import torch dot optim as optim. Okay, just run this one. Now you can, it will not give the error. Okay, now it works fine. Now it starts to create a training. Okay, now you have to train the model. Okay, so for that you have to just use how many epochs you want. Here I am just using only 10. Okay, for training the model, because it will take so much time. So for train also it will take approx 5 minutes or 6 minutes. So what you can just do, you can just write epochs equal to 50 or 60. You can just try for that, so that you can just see if how every time the loss is decreasing. And the second thing is that you, whenever you are just writing the epochs, you can't directly write 1000 epochs or 2000 epochs. You have to see at what, after what epoch the training accuracy is increasing and validation accuracy is decreasing. So that part you don't want. Okay, or training loss is decreasing and validation loss is increasing. Okay, so at that case is a overfitting problem. So yeah, that is the tuning part we have to do. So I think you know if you are doing now this problem. So then after that you have to write the batch size. Okay, so I want batch size as the 32. Okay, then after loss I will just create, we will just create a loss list, so that whenever we will plot this particular loss list with respect to every epoch, and you will see that after every epoch how the loss it is decreasing. Okay, then what you will just write here, for epoch in epochs. Okay, now you are just writing the training function, and total loss you are just initializing with 0.0 we can just take. Okay, then after that what you will just iterate through for n in range of that particular length of data set. Okay, already we have just data set that contains, and then after divide by total of batch size. Okay, that is now, because what will be the data set length is suppose 200 and you have batch size is 32. Then for every whenever you will pass the first, then that particle will have how many batches. That's what. Okay, suppose it's basically what you are just doing, you are just dividing the data set, how many time you want to iterate this one. That's it. Okay, so if suppose you have total 100 student and you want to feed in every, you have total 80 students. Suppose you have 80 students and you want to, and total batch size you are just taking as a 10. Okay, so how many times it will iterate? It will iterate 8 times, no? So you are just dividing total 80 divided by the batch size, that is 10. 80 divided by 10, so every class will have 8 student. Okay, that's what you are just doing. The similar with what we are doing now. Okay. So then after that, what you will just write here, data and the target. Okay, so data, it will just return data, and also the target we will have to write which one they will just return. So data set already you have just defined there, then you will just see, and what you will just write here. Okay, from where to where you want. Okay, so we want from the particular, okay, we want from particular n, total number of this particular, this is the n what you are just doing. The first you are just doing this, and n into particular batch size. Okay, and then after, from where you want, from n plus 1, you can keep it in bracket, n plus 1 up to, and into divided by the batch size. Okay, you are just doing slicing, that's it. I don't need to explain this one, this is really simple. Okay, so from this particular data set you are getting everything. This is the data set, no? You already defined this one. This is what I am speaking. So you are just slicing the images and you are just getting the data and the target. This is what is it is returning, no? This one, data and the target. Target data will be basically the images that will be in the tensor, and the target will be our labels. Okay, then after that you will just feed to this particular model. You will write ypred, what model has been forward. From model you already have no created the model, and from model you will just call this particular which method, forward method. Okay, and you will pass this particular image. Okay, this particular means data that will be in the float format, you can just write. Okay, from this you will get some prediction, and then after you will just compare with the loss. Okay, loss function you already created, and inside the loss function what you will just write here, what the model has been predicted. Why pred, I can just leave it, no problem. And what is the actual is the target. Okay, so this, from here you are just getting the loss. Then for every image you are just adding to this particular total loss. Okay, so total loss here you can just see, for every epoch total loss plus equal to what is the loss. Okay, so you will able to see how much you are getting the loss for every epoch, and how after every epoch the loss it is decreasing. Okay, then the crucial step here, what you have to do, optimizer, you can just set optimizer dot zero grade. You are just clearing the gradient. Okay, grade here, what you will just write, clear the gradients. Okay, then after that you will just write loss dot backward. Loss dot backward, basically that it will just calculate the gradient. Okay, and don't need to write full stop. Why I'm writing full stop? Clear, sorry, it will just calculate the, you can write C also. Okay, I can write calculate the gradient. Okay, I'm just making the continuous video. Okay, that's why sometimes. Oh, okay, so you are just calculating gradient. Now you want to apply for that particular each, what you can just write with optimizer dot step, what you just write, you are just applying the all the gradient, means what you are just updating the weights. Now that's it, means this is the formula, you know, I think if you don't know, w equal to w old minus learning rate into gradient. Okay, so this is how you are just updating the weights during the back propagation. Only the main function is to update the weights where the model has done the mistakes. Okay, and you will give the more priority to that particular neurons that is most important. That's what you are going. Okay, so you are just give the most in particular, you are just add this particular to weight, and the least important you will just subtract the weights. Okay, I think you don't have any down. Then after that what you will just write here, the loss list for the every epoch you can just write there. loss list dot append, and here what you will just write total loss and divide by the batch size. That's it. Okay. So from here you will get the loss. So yeah, now we will just print epoch. Okay, so you can just write here epoch. I have to write inside, not outside. Okay, this is the placeholder you are just creating. Then after, for the loss, what you want to write here, for the loss you can just write placing again placeholder, and inside that you want to write total loss divided by n. Okay, so I don't think so you have any doubt in this. If you have any doubt, you can just say me. Okay, I think better option, write the format. That's it. It's like ugly. Just writing epochs, then after loss you are just writing, okay, training loss, creating the placeholder, and just write 0.2f floor means 0.2f floating value you want, and on format here you will just what you will just write here. First of all, you have to write here dot format, and from what you will just write epoch +1, and then after y, because it will count from by default 0, and the loss will be basically what, total loss divided by n. Okay, so I don't think so you have any doubt. Let's run. Hope so it will just give you the error. Wow, it is giving me error. So what we can just do now, unexpected EUF only, don't worry for that. You have to just write one more bracket, that's it. For epoch, in epochs, init object is not travel. Why? Because I have done the mistake. Wow, I'm damn sometimes. Write the range. Sorry for that. I'm doing silly mistake. Not implemented. What does it mean? Rise not implemented or self comma index. What you have done the mistake? N cross. I'm writing batch size into n plus 1 batch size. That's it. Yeah. So why it is not implement error? Not implement error. Let me see. So this type of error you will also face. So it's not, I'm just not coming from preparing directly, I'm just not writing from anywhere, so I'm just seeing, I'm just implementing from scratch how you will do also. So you will also face this kind of issue during the starting phase. Okay, so no worries for that. Okay, so what it is saying, not implemented error. Not implemented error means that particular error, I have done something mistake that is in the this particular data target data set that is here. Okay, and from there what you want to say, you want to say you are just, it is calling from the get this item. Okay, get item, what I've done mistake there, let's see. Oh, I said now I'm doing very silly mistake today. Again not implemented, and it is for the same thing. Why I can import now get in this particular get item only, I'm just getting some error. And what the error in the get item? Okay, let's see. No worries. So what in the get item, you are just passing self comma idx, that is the for every index, and you are just creating the images. But why it is giving me not implement error? I don't think so I have done any mistake. Get item GET ITEM. What we can just do, what we can just do, let's see. I'm sorry for that, I'm just thinking what should we do. We have to look again self images list. So you have just created the images list. In that you have just passed for every index, okay, in that particular get item. Similar for the label, okay, get item. One time I can just run everything. Let's see if it is running. Oh no, it's not that error. That's why I'm not running. That's why it. I think, yeah. Oh, only this particular I have just run. I am not run this particular, so it holds the before what it has been. That brain MRI data set. Okay, so no worries about that. And this error is really even what's the runtime error is the expected 4 dimension input for the 4 weights like 256 1 comma 3 comma 3, but got 3 dimension of the size 132 comma 128 comma instead. So what, where I am just getting this error, I am just getting error in the forward. Okay, so model dot forward, in this particular I am getting the error. So what the error it means, you are just directly you are just passing a model dot forward, and from that you are just passing float value of data. Okay, that what you are just passing, and here it is the from data set you are just selecting n batches. Yeah, it's not an issue. Hope so. We have done something mistake in this convolution neural network. We can just see there, we can just see from the starting. Even I can do pause and I can just solve, but I don't want to do this thing. I want to just know where you are just doing the mistake, and from where, and that how you have to just improve. Okay, and how you are just where it is mistake and at what point it is mistake. Okay, you should know this all things. So what we have done, you are just creating the simple CNN class inside that, and you are just you writing convolution neural network. Yeah, I'm just writing the same thing. And then after you are just writing kernel size also 3, and then after you are just writing max pooling, then again you are just writing convolution 2D 32 kernel size as 2. That's it. And then after you're just creating a linear layer, the first you are just writing 62 128 128 comma 64. Then after you are just flatting, oops, you can just pass one, you can just see now. Oh, I know that's the it will not give any change because you are just passing by default it is 1. Again you are just creating another self dot linear 126 126 976 comma 2. Then after that you are just creating a forward method that consists of the convolution 1x, then after self linear 1x 2x flatten, then after self dot linear 3x, and then return. Okay, so I don't think so you have done any mistake there. So it's, I think mistake it is in there this side, this particular. And what the mistake is that particular expected 4D dimension. So here they are just expecting 4D dimension, but you have passed only the 3D dimension. That's what you are doing now. So for that you have to do for n in the range from the, you are just passing length. Okay, I thought I have done mistake there only in adding the array. I don't know, but yeah, I know this one because what you can just do, you can just comment this one, and you can just print data dot size and break. Okay, and also this also break. You can see what will be the output. Let's see. Yeah. You are getting, yeah, you are getting 32 comma 128 comma 128, but you want that because conversion 2D they accept 4D dimension, total 4D dimension of that particular image. Okay, So what you can just do, I think you have to, whenever you are just creating the images, at that time you have to convert, you have to do reshaping there only, because this here, because we are just creating only 3D dimension, but the convolution neural network they expect 4D dimension. This mistake I have done. It can be, you can also do this type of mistake. It's not any big mistake, but yeah, you should learn from that particular error. So what you can just do here, I think array you have already, you before, I think before this one, appending this one array, what you can just write here, I want to change this particular array, I want to resave this array. How you will just resave? Array dot resave, and then after that what you will pass here, 1 comma, I am just adding one more dimension, self dot height. Already I have self dot height, the comma self dot width. Okay, now I think she will not get the error. You are just adding one more dimension, that is 1, and 1 represent, that is grayscale, you have only one channel, that's it. Okay, hope so now it will works. Now you're getting the this dimension. Yeah, so remove this one. No worries, if you will get more error, we will look out again more error. That's fine. Don't just say that if you are getting error then you are not doing anything. You are just learning from that particular error. Okay, don't worry for that. Yeah, hope so now it will work. So if it is working, then for the particular total number of epochs you have passed in, but you can pass more number of epochs to get a much more accuracy and much less loss. Okay, so then after that what we can just do, we can have to just plot this particular. Okay, so plotting, if it is training, we can just see for the first epoch if we are getting, then we will just write and plotting. Okay, for plotting for this particular model. Okay, for after every epochs what we will be the output. So what you can just do, let it will run, it will take some time. So before this one, what we can just do, we can just plot plt dot, we can just write figure equal to plt dot figure. We are just plotting with the help of matplotlib only of the loss with respect to epochs. Okay, that's it. What you are just writing, figure size what you want to take, just write here 10 comma 10. Okay, that's it. You can just write this, how we are get the, for the first epoch we have loss, wow, training loss is this much. Okay, so don't worry, I have passed, that's only the 10 epochs. So you can pass 100, that's why every time I'm speaking I will get higher loss, but you have to maintain this one. Okay, it will be like approx 0.01 or 0.5, like 5% or 3% error. That will be our best model that we can just say. Okay, so what you will just write here, fig, then after that what you will just write, plt dot plot, then after that list of all the range of epoch what you have passed. Okay, then this will be your x, then after that what, then after that what is the one will consist of the y. Okay, y will be your loss, this particular list, loss list. Okay, loss list. Yeah, so I hope so we don't have any doubt in this. Then after that you will just write the plt dot title is basically for what and what, it's basically for the loss versus epochs, that's it. Okay, then after that what you can just write, plt dot x label, and here we will write here epochs, and then after you will write plt dot y label, basically it will be the loss. Okay, and then after you will write plt dot so after running this particular, it will just run. Okay, so hope so we can just run this also. So then after that, after running total 10 epochs only we have just given. Okay, don't worry for that, we are getting approx, yeah, that's the every time the loss is decreasing, you can just see this one. Then after that what we will just do, so you have done the training part also, you can just pass at least 50 epochs, you can just pass. Okay, So you can also visualize this particular, okay, like for the particular you want to see this particular image, okay. So how you will just write here, okay. So for particular map you can just write here, like for the images, that particular images you want to see from this particular images, you can just take only that particular images, and how the model is prediction during the prediction time, how you will see for the unseen data, okay. So you can just write this particular, what I'm just writing this particular, what for you will just repeat for 0, we can, you can just say if any particular model has predicted 0, then you will say is no, okay. No means that does not have any, or this particular what you are saying, sorry for that, tumor, okay. And if you have 1, then you are saying yes, okay. Then what you are just writing here, you are just yeah, see this graph will plot. So this how I was saying, okay. This is the what you are just getting the loss result, means you are just see how the loss is decreasing. Then after it's gone, it will again decrease how many epochs you will take, okay. This how this loss graph you are just plotting this one. This the model has been trained successfully, and this is the last step. What you want to see, if suppose you are just passing some images, you want to see, you have trained this model, but this model you want to use in the real world data, okay. How you will use this one, then just write plt dot figure, and then after what you will just write figure size, and then after you will just pass it 20 comma 20, I want only 20 comma 20 figure size. Then after you will just iterate for I want total 20 images, okay. That's what we can just for I in range of 20. And then after what you will just write data comma target, it will be the same way of the training what you have done, data target and everything, only you will not update here the weights, okay. That is optimizer or anything. What you will just write here, data set I for every images you are just taking, and what model will predict, what you have to just write model dot forward, what you have written the same thing in the training there also, and you have written data dot float, okay. I don't think so you any problem here you have. Then after what predict, okay. Predict here you will just write torch dot argmax, okay. Argmax basically says that, okay, torch.argmax, here you will just write predict, and from which particular dimension you want write dimension as 1, okay. So basically it will give you this particular in the output you will have two neurons, one neurons will deal with the no, and other second neurons will deal with the yes, okay. That if you are, which particular neuron will fire, which has highest total number of values in that is the probability. If the yes probability has 0.7 and no probability, no neurons has probability 0.3, then you will automatically will say 0.7 model has been predicted, means that particular neuron holds 1, okay, and 0.3 holds 0, that means does not have tumors that holds 0.3, and have tumor that holds 0.7, that is high more probability you are just getting. That's what you want, okay, which you are just saying which particular neurons that model has been predicted, okay, from dimension along the dimension axis equal to columns, okay. Then after that what you are just write, you want to subplot, for that you are just going for the 20 images, okay. Then what you will just write here, plt dot subplot, okay. You want from 4 comma 5, and for every it will just increase I plus 1, okay. This then after just write plt dot im, so that's it. It will display this particular image to every subplot, okay. Data, the first data from 0 to 0, the first data for the first row, and then after the particle the first column, okay. Then and then you want to convert this all thing into cpu, because why, because matplotlib does not work with the tensor, they works with the torch, okay. That's why I'm just repeating this one. So you can just convert into the cpu. Then after that plt dot title, you can even you can just mention, so that you will able to see, okay. You can just write app string, you can just go for this actual, what you are just getting the actual, and then you can just mention with the mapping of that particular target, okay. Okay, you want to map of that particular target, and for that what you can just do, you can just convert that thing also to a cpu, okay. And after detach, you can just do detach also, okay. So from detach you would want the items, okay. So basically it says that you want all the what the model has been predicted, and means what the actual value it is and what the model has been predicted you want to see. Okay, whenever you will just plot the all the images in the above, it will be written what the model has been predicted and what the actual level of it is. Okay, so what you are just doing now. Okay, so from this details you will get the actual level of that particular, and then after the second what you will pass prediction of that. Okay, prediction, like you have to pass the prediction also. Then what you will write prediction, you will write prediction. Then after that you will write the same as it is here. You have to write the mapping of the same. Even you can just copy paste, that's it. Okay, so I don't think so you have dot in this also, but here you have to change something. What you have to change, you have to change for the pred, you don't have to write the target, what the model has been predicted. Okay, and just right after that you just write plt dot so I know it will some, it may give me, let's see, hope so it work figure size with 0 axis. Why figure size with 0 axis? Wow, today I'm getting too much error. Okay, so you are just plotting, then after that you are just plotting the figure, from that you are just plotting total 20 range, and from there you are just getting data target from data set. Okay, so why I'm getting this error, figure size 144 with 0 axis. Okay, 0 axis, then after you are going to the prediction forward. 0 you are representing as a no, and 1 you have represent as a yes. Okay, what you have done now, and then after you are just plotting plt dot figure size as 20 comma 20. So what the error for this, data and target from the data set is this one, this particular data set. Okay, so for this particular data set, and you are, yeah, you are just getting sorry. Okay, so what you are just getting for what you can just do now, wait, I can again, I have the option, what you can just do, you can mention, what you can mention, yeah, this data what you have passed here for every range, for I in range of 20, just run this one, print data, if it is running or not, see. Numpy object no attribute values, I have written something somewhere like values, or I have written value, it is showing me error in this, and then after, okay, I got it, it is error of this one only. Okay, so what I have written there, so here see the first, the type I have just mentioned there, if the type is particular the string, so you are just converting this thing into, it is particular type is a string, you are just converting into image list, list image list, you are just converting into image list, image list, or converting into list if that particular it is a string. Okay, and if it is, if not is a instance, then what you are just doing, label list. Oops, sorry for that, I have written here only values, sorry. So what you are just converting label list, then after you are just converting into integer format. Wow, so just run this one and run last one, let's see if it is running or not. Wow, so now we are getting the result. Again I have done the silly mistake, so hope so this time we will not get the error. Just write this string and remove this one, run this one. Oh wow, now you are seeing this one. See, actual and the prediction. But here it has been PLD dot subplot. This is actual, no prediction, yes, no. See this, it has been predicted, no. This also it is predicted by, yeah, means model is predicted correct. This also model is predict correct. This is also correct. This is wrong. This is wrong. This is also correct. This is wrong. This is correct. 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 Okay. This is how it is going, because only I have just given 10 epochs. Okay. You can mention like good amount of epoch. Okay. So yeah, so hope so you will get this answer. And then what the second thing what we can just do, even I can mention this thing in the horizontal way. Okay, so for that what we can just do, already you have just plotted the figure and you have just mentioned torch dot arguments from the dimension 1, and you have just made a subplot, and subplot you are just writing I plus 1, and you are showing all this thing into CPU. That is only the target, that is the target, that's it. Okay, so even you can just pass what you can just do 5 comma 5. Let's see. Okay, so no worries about this. I'm just getting everything in the horizontal way. So but still we are just getting the some result. Okay, so what this was the really long video related to the brain tumor detection, and this particular, from this you are able to see, you can just pass any image. Okay, I have passed on the data set that already I have just loaded. So here you are able to see from what you are just getting the actual and what is the actual of that. Okay, even you can just pass only for the 10 or 5 year you want to see. Okay, that's it, don't have to pass everything. Okay, only the 5 only I'm just seeing. Okay, this is actual, and from there you are just getting yes, no, this correct. Okay, so how you will get this result actual and what is the prediction. Okay, so this how you can just decrease more loss with the help of, if you will increase the number epoch. Okay, you can just mention at least number of epochs as 100 or at least 50 to 60. Okay, so you will get more loss, more low number of loss. Okay, so yeah, this was about the brain tumor detection using PyTorch CNN model. Hope so you like this video. Then please subscribe our channel, so that in the next video we will see the different kind of data set. Okay, so yeah, so that's it for this video. Hope so it was very long video, and yeah, I was shooting continuous, even I have done some mistake, so I will just stick with you so that you can able to see what mistake it is coming through and how you are just dealing. Okay, so yeah, that's all for this video. Thank you.